Hello, and welcome to Sterling and VMware's Power Block session. I am Megan Moore, Sterling's VMware Partner Business Manager. We know your time is valuable, so we want to say thank you for choosing to spend a portion of your day with Sterling and VMware. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. Sterling is a principal VMware partner and a preferred services partner authorized to sell and service VMware solutions to customers across the nation. With 50 plus technical staff and 75 plus sales staff, all trained on VMware offerings, we are sure to provide you with an industry best value on all of your client to cloud IT needs. As you can see from this slide, Sterling holds many VMware competencies, including 2 master services competencies and more coming soon. Next slide, please. Sterling offers complete customized solutions from client to cloud. We serve on multiple federal, state, and local government contracts and support all industry verticals. Security is of the utmost importance at Sterling. We have a robust, secure supply chain, including OTIPs and CMMC certifications. For any questions about Sterling, please use the email aliases that you will find at the end of the demo. For questions about the demo, please put them in the Q&A feature at the bottom of your screen, and we will address them at the end. Now I will turn it over to Cloud Architect Billy Downing to demonstrate the VMware's vSphere with Tanzu environment using Helm.
Awesome. Thank you, Megan. So like you said, my name is Billy Downing. I'm a cloud architect here at Sterling. And here's the agenda of what we're going to talk through today. So we've already kind of gone over who is Sterling. So what we're going to talk about after that is going to be our solution statement for what we're actually trying to solve for and the different products that we're going to use to solve that problem. And in general, we're going to go ahead and take a look at what a vSphere environment enabled with Tanzu and NSX it looks like when we're going to deploy applications in a packaged way using Helm on top of them. So at first, we're going to just do a Kubernetes overview. That's just to level set what Kubernetes is and how it's kind of involved in the system we're using today. And then once we have that backing of what Kubernetes is, we'll talk about how that actually is integrated with vSphere and what vSphere with Tanzu, and in this case, I also have NSX and what that looks like and how it actually integrates. Then we'll take a look at what Helm is from an overview perspective, just talk about what it is and how we're going to use it today, an architecture of the demonstration that I'll be doing, and then we'll actually dive into the lab environment that I have running a vSphere 7 update 1 and NSX 3.1 using Helm 3 to deploy a containerized application and upgrade it in our vSphere environment. So first, for the solution statement, we'll be talking about Kubernetes, and I don't plan on reading everything on this slide, but I wanted to make sure that we try to just segment and categorize all of the different products we're going to be looking at today. Kubernetes is an open source project coming out of Google, and this is an abstraction layer for application runtime. So we'll kind of jump into an analogy of what Kubernetes is in a little bit. But essentially what it is it provides a platform to run and orchestrate containerized applications, as we'll see demonstrated on top of vSphere in this case. The next solution that we're going to look at, which works in tandem with Kubernetes, is called Helm. And Helm is a package manager for Kubernetes. So it's very much so similar to Yum or apt-get or things like that you would use on normal Linux distros. It's a way to go ahead and take your distributed and microservice-based containerized applications, package them into a nice little form factor that is referred to as a Helm chart, which allows you to quickly and rapidly install and deploy applications, whether they're built in-house or whether they are standard applications that you find necessary things like a SQL Server or things like that are just deployed on a consumption base for your applications. And the final piece of this is vSphere with Tanzu. So the goal here is just to kind of talk about how we're able to enable our existing vSphere environment for Kubernetes to help with our cloud native application development, and gives ourselves a platform to run all of our containerized applications and then deploy them using Helm, and how we're going to look at that going forward. So first, I'll start off with just a quick analogy of what Kubernetes is and how it relates to what we're going to be solving, what problem we're going to be solving today. So the analogy I like to use is that of you're going to some sort of gift exchange and you want to figure out a way to give all of your friends a present, but you want to do it in the most efficient way possible. So what we start out with is, say we go to a store and that store gives us these 5 gifts, but they package them all in a single, one single box that they expect us to take and then hand out to our friends individually. Well, the problem is this, that now each gift has a dependency on one another. So if we open that box, it tarnishes the wrapping and all that good stuff. So now each gift is completely dependent on the other gift. So we are unable to treat them as individual entities, and we're not able to give each gift to a person at an individual setting. It has to be a group setting. Everything we do to manipulate the gifts all has to happen at the same time. So our solution to that is open the box and break out each gift individually, and then go ahead and wrap it. So now we have each individual gift wrapped. And the problem now we're able to go to that party and hand them out to each person individually. But now the problem is that we have all these gifts that are kind of unwieldy to carry. It was kind of nice having them in a single box. So now that we have, 5 gifts we're trying to juggle around, we do something like put them in a loosely based sack. So rather than kind of wrapping them all in a single box, we're going to put all of the individually wrapped gifts in some sort of a tabletop or some sort of a platform that we can use to house all of these gifts so that we can hand them out individually whenever we need to. So how this relates to Kubernetes and application development, going from left to right, from having that monolithic application or that single box for all of your processes or all of your application dependencies in a single virtual machine, is similar to getting that gift with all 5 of the contents in a single box. Everything is tightly coupled. Your packaging must accommodate all processes. Any sort of upgrades or anything like that across each one of your processes have to happen in tandem. And nothing can be really done individually. So this is kind of a depiction of a monolithic application. So the next step from an application process, going down towards that cloud native development process, the next step is going ahead and breaking out each one of those processes into what we refer to as containers. So if we look at it from a perspective of 1 container per process, we may end up with 5 separate processes, but there's still, again, just like the gift analogy, they're loosely coupled in the sense that there's no central way of managing all these different processes. It's great that we can go ahead and develop each one of them individually and deploy them as individual entities to make up a whole system or make up a distributed system as a whole. However, we run into that problem of management and orchestration for our entire environment. We end up having containers that we have to then treat like each individual pets. So the next step is towards that cloud native application development model is where Kubernetes comes in. So Kubernetes changes the paradigm from each one of those individual processes and individual containers that are treated like pets, and ensures that the application as a whole is treated like a lump of cattle. So now with Kubernetes, you have a lifecycle awareness of all of the containers built inside of pods, and you have the ability to go ahead and manage that entire application while still getting the benefits of individually developing each process as a separate entity, but using Kubernetes to couple everything together. So in that sense, we've kind of come through that whole process of a monolithic application all the way to a cloud native developed application running on top of Kubernetes. Kubernetes being that analogy to that table or that platform that's providing all of your services to run in an organized manner that you have complete control over. So now that we know what Kubernetes is, let's talk about how that actually integrates into vSphere or VMware Cloud Foundation with Tanzu in this architecture here. So starting off from the foundation, I have here listed as VMware Cloud Foundation on VxRail. This is not a necessary component. I just have it here for to show all the different options, or the most complete solution brought to you by Dell and VMware, and how those kind of integrate together. But VMware Cloud Foundation isn't a requirement. You can run this on native vSphere without having SDDC Manager or VxRail involved at all. You can have a normal 3-node cluster just running vSphere 7 or vSphere 7 update 1, and you can enable these different types of functionalities to give yourselves a Kubernetes platform to run on top of vSphere. So going along with that VCF kind of idea here, we'll start from the bottom and work our way up. So when we're enabling a vSphere cluster with Kubernetes, the first step is we have these 3 different entities of compute, storage, and network. So in this case, we're going to be using NSXT for network. We're going to be using vSphere and vCenter for our compute orchestration. And then I have vSend listed here if you're using VCF. However, that's not a requirement as well. So for example, in my lab, I'm not using VCF. I'm using an FX2 connected to a Dell PowerStore. So those three entities are for more of that hyper-converged architecture for Kubernetes. But in this case, it's not necessarily a hard, fast requirement. So the first thing you're going to do is when you enable Tanzu is vSphere is going to take care of that deployment of a Kubernetes master node control plane on top of vCenter or on top of your vSphere environment for compute. So we see here we have three Kubernetes masters, also referred to as supervisor masters. As we'll see kind of in the UI, that'll make a little bit more sense later on. So what this actually does is deploy a virtual control plane. So much like vCenter manages bare metal ESXi hosts as hypervisors, we'll deploy virtual Kubernetes masters and then enable our ESXi host to install an ESXi ported version of kubelet so that those Kubernetes masters can then use ESXi hosts themselves as Kubernetes bare metal worker nodes. So going up, we each have that namespace concept that we'll take a look at in the UI, a form of segregation between your applications and how they run. And then we can see here within a namespace, we can either run a vSphere pod or we can run virtual machines. So this gives you the ability to use your existing infrastructure you have today running virtual machines on vSphere, as well as running what's called a vSphere pod directly on top of your ESXi hosts, not in some sort of nested virtualization necessarily. So what is a vSphere pod and how does that actually work within an ESXi host? You might be asking, ESXi isn't Linux. So how would you run a Linux container on top of ESXi? So how that's done is this is referred to as CRX, as the container runtime that VMware has developed to run on ESXi. And here's just a kind of a breakdown of what that looks like from an actual perspective and the different layers that go into enabling ESXi to run Linux-based containers on top of it in a somewhat bare metal fashion. Another option that you have is to deploy virtual clusters on top of your ESXi hosts, which is going to then still be managed by your underlying Kubernetes control plane. It'll be using a project called a Cluster API to manage those. So essentially, you get into an instance where you have Kubernetes, your bare metal or your bare metal Kubernetes instance on your supervisor cluster that can be managing different Kubernetes clusters that are referred to as TKG guest clusters. Then on top of those TKG clusters, you can run native Kubernetes pods because those TKG clusters are based on Photon. So they are actually running Linux. So you don't require that same CRX runtime or the different shims that are kind of highlighted above the vSphere pod. So at the end of all of this, essentially what you have here is a complete platform that provides you with NSXT for networking, vSAN or any storage for storage, vCenter and vSphere for compute, enabling all that to manage your Kubernetes control plane to then deploy either vSphere pods directly on ESXi, manage your native virtual machines that you have already existing in your environment, as well as deploying guest clusters or multiple TKG clusters on top of your environment and all of that still managed through the vSphere UI. Okay, so that's kind of going over what is Kubernetes and how is Kubernetes integrated into vSphere using vSphere with Tanzu. So the purpose of what we're trying to do today is now that we have this platform built out, what is the next step? So typically the next step is we develop applications or we grab applications from a catalog and then we want to run these applications. So what Helm does is it kind of takes off from where we ended with that Kubernetes analogy, where we have a platform that's running all of our loosely coupled microservices and containers and pods. And it takes that one step further to help kind of organize all of that, because the one downside of running everything in Kubernetes and using the native tools is that you might end up with a flurry of different YAML files for all the services, all of the actual deployments, all of the PVCs, and all the different objects that go into making a distributed system successful. So what Helm does is it grabs all of those different application files you write, all those different YAML or JSON files, if you so choose, and it kind of packages them together in a way that allows you to consolidate all of your different artifacts for your application into a single Helm chart. So rather than having to understand the application intricacies, it allows you to go ahead and deploy applications without actually having to know all of the minute details that go into, the order of sequence, or what PVCs and storage classes to use, or what images are actually available for your deployment you're trying to work on. And what Helm really does is bring it all the way back to the idea that you have one application made up of several disparate services that you want to deploy on a platform. So for our environment, it's essentially going to be two different, we have on the left-hand side, we have our developer role, or our vSphere administrator role. And that's the role that, I'll be kind of playing from there, from deploying applications using Helm, and I'll be deploying them directly onto our physical infrastructure. And that physical infrastructure is obviously abstracted by vSphere and Kubernetes to create that private cloud environment. So what we'll see is that as I deploy an application, it's going to create all sorts of objects that I don't have to actually do myself. It's all automated through, because it's all packaged through Helm. And like I said, a huge benefit of that is, imagine if you have a very intricate, very sprawled out microservice architecture for a specific application that's grown in-house. You hire new administrators to take care of that application. If they use Helm, they can then to be able to deploy and upgrade that application without having to understand every single minute detail. Once those charts are created, you can use Helm to lifecycle that application going forward. From a developer perspective, Helm can also be integrated into any sort of process that you have for generating artifacts and deploying them through some sort of a GitOps model, or whatever model you're going to be using for deploying applications on top of your Kubernetes cluster, in this case, on top of vSphere. So with that, I'm going to go ahead and jump into the actual environment. And what we're going to do is take a look at what does vSphere with Tanzu look like from the vCenter UI. We'll take a quick look at the different components that are integrated with it. So we'll look at Harbor as our image repository that's directly deployed and managed by vCenter. And then we'll take a look at NSX, how it actually works, and what are the intricacies and services that NSX can provide. Then we'll go ahead and deploy an application with Helm. We'll upgrade that application, and then we'll just take a look at the different options that we have in packaging those things and how they integrate with vCenter specifically, or how they integrate with vSphere with Tanzu, I should say. Okay, so here I am in my actual UI. So let me make sure I'm still logged in here. Okay, so what we're looking at here is just a simple 2-node cluster. So like I said, this isn't VCF. So the VCF, like I said, is not a requirement, although it does help with the automation of the entire platform, obviously. There's benefits of that. If you want, we can have different discussions on that. But what I have here, the 2-node host, and you can see that I do have all of my legacy virtual machines running on here still. So this is like a normal environment that you have, and enabling Tanzu is more of an after the fact. So there's no, you can easily integrate this with a brownfield deployment without interrupting any of the services you have today. Then we can break it out in this concept of namespaces. So because this cluster is built out in a way that Kubernetes, the supervisor control plane VMs here, these are that virtual Kubernetes cluster or Kubernetes control plane that I was referring to earlier. And these supervisor clusters are the management plane, whereas my ESXi hosts actually make up the data plane for this actual environment. And so if I go and take a look at how this actually looks in the UI, I can see that I have these control plane VMs, and they're going to be managing my physical ESXi hosts. So then what I do next is I create these concept of namespaces to segregate workloads. And within each of these namespaces, I have the ability to control exactly who can access this. I have the ability to access what storage they have access to, as well as monitor and set limits on what this resource pool or what this namespace can actually deploy in their environment. And like I said earlier, within a namespace, you can deploy either vSphere native pods. So you can see here that I do have several pods that are running within this namespace, but you can also deploy and manage TKG guest clusters. So we see here I have a TKG guest cluster made up of 2 nodes, one control node and one worker node. And this is actually a guest Kubernetes cluster that's being managed by vCenter. But it gives me the ability to maybe test out a new version of Kubernetes, maybe test out deploying more advanced tools, perhaps like a service mesh that can integrate directly with my guest clusters and things like that. It also gives me the ability to have an idea where I can deploy applications per cluster rather than applications per namespace, if that's your preference. At the end of the day, it really just gives you that flexibility to either deploy and manage vSphere pods natively on your bare metal ESXi hosts, or you can run TKG Kubernetes guest clusters on top of it as well. So taking a look at this Helm demo, this is the namespace that we're actually going to be deploying some pods into and taking a look at it. We can see that it's running Kubernetes. I believe this will tell me the, thought it would tell me the version, but we can see that where this actually, the compute for this is running, what vCenter is managing it. And then if you were to hand this off to a developer, so say you're a vSphere administrator and you wanted to go ahead and create this namespace, set up some parameters, and then give it to a developer. All you have to do is build this namespace. For example, in this one, I have rights to edit this. The administrator has provisioned me, or I've provisioned a storage policy to know where any sort of PVCs or persistent volume claims that I make, where those will actually be instantiated on the hardware resource. I can go ahead and also set limits on here to say that you can only use this much compute or this much memory going forward. And this is just a management of the different clusters that I might have if I'm deploying guest clusters within this namespace. So what I would do is I would create this. I would then give the developer a link to get to this page, but this has instructions on how to actually log into the cluster and what to actually do from there and how to actually start consuming these Kubernetes or this Kubernetes platform as a service, which is essentially what you get out of all this. So now we've gotten to the point where we have Kubernetes running on our vSphere environment. We have our namespaces built. We have our developers provisioned access. So now the developers can do whatever they want with it. If they want to deploy their application directly to the namespace using vSphere pods, they have that ability. If they would rather deploy applications based on that are broken out by clusters themselves, they can deploy several TKG clusters and then deploy the applications within there. For example, if you wanted to use per application, a dev and production Kubernetes cluster to separate them, you can do that here. And those are all into the access of the ability of the developer themselves. So once you've provisioned the namespace for the developer, they don't have to request any other access from you as the vSphere administrator. They can go ahead and it's a completely self-service environment to where they can apply their Kubernetes manifest, or in this case, they can use Helm to then install all of their different applications. Let me just find my mouse here. Okay, so now if I'm looking over here and I am the developer, what I'm going to do is go ahead and log into this cluster based on the instructions that the administrator gives me. So I'm going to use my account to log into the cluster. And once I log into the cluster, I'm shown the different contexts that I have rights to that are built into my Kubernetes config file. So we can see here I do have access to this Helm demo. So all I'm going to do is change my context over to that Helm demo. And then let's just see what I have going on here. So this should show me, these are the actual Kubernetes environment that I'm deploying to in this namespace. So like I was saying earlier, I have 3 virtual machines running as my control plane. And then those 2 ESXi hosts are actually my worker nodes in this instance. So if I deploy vSphere pods, they're going to run directly on these ESXi hosts. If I deploy TKG clusters, they're also going to run as virtual machines on these hosts, but they're going to be managed still by that same control plane. So we can just take a look at here and just see what's going on. There's not a lot going on in this namespace, so there shouldn't be many artifacts. These are just the CRDs that are involved. But we can see, let's see. This is showing all the namespaces. Oops, apologies. Let's just go here. I have no pods running. So now I've gotten to the point where as a developer, I have my application. I have it containerized. The next step is how do I package it and then run it on this platform. So for that, I'm going to use Helm. And in this case, I'm using Helm version 3 specifically. I believe Helm version 2 is actually deprecated. So if you are using Helm, definitely search for Helm version 3. It doesn't require any server-side accounts like the legacy version used to with Tiller. So it's much easier, and everything you're doing is going to be on client-side facing. So what I'm going to do is just quickly, I will install an application. But before I do that, I wanted to show you what those application actually entails. So in this Helm demo, I have a directory that has my charts and my templates and my values in it. So values, essentially what this is doing is creating all of those, is curating a way to package all of those different Kubernetes manifests that I have in my environment, run them through a templating engine, and then deploy them as a single entity that I can then version and upgrade from using Helm as my basis for that. So I have my templates for my actual deployments that I'll be running here. So it's a very simple application that I'll be running. It's essentially just a 4 container application, a web front end with a Redis backend. It'll be claiming storage from my vSphere environment, as well as creating a external facing load balancer using NSXT. And it's going to be pulling images from my Harbor instance, which is deployed directly on vSphere and managed by vCenter as well. So what I'll do is just install this application. So I'm going to install this application is Go Figure 01. And so what I'm trying to highlight here is from the perspective of someone who might not understand the application intricacies or understand the different microservices that go into it. I can jump in here and someone can tell me that, hey, here's your Helm charts, here's your repository. Can you please deploy this application? So what I'll do is go ahead and deploy that application. And what it should do is provide me, what it's doing right now is going ahead and it ran all of my different templating tools, my deployments, my services through a values templating engine and deployed everything to it. So you can see here, it's telling me what images it actually used. So here's the location of my actual Harbor instance that's housing my image repo. You can say it's in a deployed state, and this is revision 1. So now if I do a Helm ls, let me actually make this bigger. So if I do a Helm ls, I can see my application, the namespace that it's running on, when it was last updated. I can just see the overall status of my application. And now if I go back into my Kubernetes cluster and see what's going on with that, I should be able to see all my pods are up and running. So let's just see if I actually did provision a service for this on NSXT. And let's go verify this is actually working. And then I want to show you what actually just happened. So when I did that simple Helm install command to get this application up and running, what objects did it create and how did it interact with the different components of this platform to do all of that on my behalf? So first, let's go here and let's just make sure this application does exist. First, let me get this Zoom thing out of the way. And I had it running on ports 8081. Okay, so here's my simple application. It's nothing fancy. It's really just using for demos. It's basically a, sign up and build things and log in and whatnot, but it's just called Go Figure. So this is a simple application we deployed. So we deployed this using Helm. So let's look at the objects that it created. And let's start with our vCenter objects. So now we can see that I have 4 pods running in my Helm demo namespace. So I have one replica set of my 3 web-facing pods, and then I have 1 pod that is my storage pod, or Redis rather. And this pod is actually backed by persistent storage that is using, like I said earlier, that Dell PowerStore that is interacting with that through vCenter using the container storage interface. So Helm was able to package my application in a way that can translate it and deploy it on my vSphere with Tanzu environment. And then it took that and it interacted with all the different components that are required from an application to be functional. So looking at, from a pod specific, if I'm the vSphere administrator and I see that the developer is deploying things and maybe they're having issues with it, I can go in here and help them understand, what different usage models are they doing, or what sort of permissions are built onto this, and what sort of data store they're actually built on, as well as the networking that's being used in this environment. We can see here that it actually did deploy it on an NSX segment, which we'll take a look at in just a second. So looking at this Helm deployment from this perspective, I have an overview of everything it's doing. So it's using 5 gigs of storage. So that was the size of my persistent volume claim that I made based on this storage policy. I can see the RAM that it's using, and I can see the overall status of the pods. I can also see the different events that are occurring, whether they're Kubernetes events or vCenter specific events as they relate to, as they relate to this namespace. I can then also check out, what's going on with this in general from the infrastructure perspective. Did I create an embedded registry place for my images to be stored, and so on and so forth. Kind of a big deal with this, it's very nice that vCenter does this for you, is that it's handling the compute, storage, and network all through one interface. In this case, we're using Helm as that interface to deploy all those different objects. So if I look at storage here and I look at my persistent volume claims, I see that I did make a claim, and this is for that 5 gig claim storage, that 5 gigs that I claimed for my Redis server. If I click on this, I can then see more information about this PVC and how it was actually created and where it actually sits. So I can see here that I have a PVC. I can see exactly what storage policy it sits under. And where it physically sits in my environment. So I can see if I'm having issues with applications writing to their data store, I, as the vSphere administrator, know exactly where that data store is, and I can go and dig into that to understand what's going on with it. If they're having issues with the compute infrastructure, obviously that's going to be vSphere. I can take a look at what are the metrics they're actually building on, what sort of RAM utilization are they seeing or compute utilization. And then finally, if they're having networking issues, I can go ahead and I can log into NSX to see exactly what's going on from a networking perspective for this application. So now I'm logging into NSX, and I just wanted to show that different objects that Helm actually went through and created as it deployed this application. So if I go over here to the networking, we can see this kind of unique network topology view that NSX provides. And this is, again, not specific to the vSphere environment. This is our vSphere with Kubernetes environment. This is something that NSX is the platform that can be used for your virtual machines, your bare metal machines, as well as all your containers. So we can see here it's kind of a verbose output of all the different hierarchical routing that I have in place here. And we can go through and try to find, where is my actual pods running? This does separate them by pods and virtual machines. So if I were to go down here, this looks like the T1 gateway that's being used for my Kubernetes environment using Tanzu with vSphere. I can go down here and look at my different segments that I have that are, actually connecting these pods together and break that out to see exactly where my pods are, what port they connect to, and what sort of metrics I can grab from that. If I want to do port mirroring or packet captures from pod to pod traffic, if I want to implement security policy from pod to pod traffic, that's something I can do all through NSX. Another benefit that NSX has is that ability, as we saw, we got to this application through a public IP address, or not public, but it's external to the cluster in hand. So I didn't have to go to one of the actual node IP addresses. I went to a load balance type service. So what NSX is doing is it actually deploys load balancers on our behalf to support our Kubernetes environment, as well as supporting our normal vSphere environment for any other virtual machines that we have. I can see here that this is the load balancer that NSX has created for my vSphere with Tanzu environment. And if I look at my virtual servers, I can scroll down here and I can actually find that IP address that is allocated as I created the application, the name of that. And then I can take a look at what's the server's pool, which happens to be, in this case, each one of these pods that are in my application. And the last thing I wanted to talk about for this application is, where did I pull those images from? So perhaps you're in an environment where you have to be completely on-prem. You can't rely on, public registries or anything like that. So when I look at back to my vCenter, where I'm actually managing this vSphere with Tanzu environment, and I go down here to image registry, this is an image registry that is directly deployed and monitored and managed by vCenter itself. It's actually deployed in a namespace that's owned by the system, and it's deployed as a series of pods in a normal Kubernetes environment. So if I go to this registry, which I'm here right now, and I log in with my account, and this is the same account that I was given access to my Helm demo namespace, we can see that when I created that namespace, it also created a project in Harbor to house all of my images specific to that namespace. And the RBAC and access control is allocated based on my account. So because my account is given access to the namespace, my account is also given access to push and pull images to this repository. We can see here that I have 2 images with a few tags, or 1 image with a few tags. This probably isn't the best practice way of doing it, but this is just the easiest way to demo it. So I have 2 images here. Right now we have the blue image deployed, and I will use Helm to upgrade it to the green version. And then I also have my backend, which is the image that's actually just my Redis backend. So this gives me a place to actually house all of those artifacts. So if you're looking at this from a CI/CD perspective, you can do everything on-prem. You don't have to have any reliance for any external services to conduct, artifact or image retention or image policy invocation for your different containers. And you can integrate all of that through vCenter and vSphere with Tanzu. Okay, so I have my application, it's running, it's great. Someone comes along and says, hey, I need you to upgrade this application. We've, say they have a manual process still, or the CI process is integrated to where it created a new image based on the new code base. It then pushed that image into Harbor. So in this case, we're saying that this green image is the new image that's pushed to Harbor. And we want to then roll that out into our application in a non-disruptive manner. So if I come back over here and I look at my Helm, again, if I look at the Helm releases that are actually out there, this is still revision 1. And so what I want to do is actually deploy and upgrade this. But again, maybe I don't know the intricacies of the different services that need to be upgraded, or the different images, or not different images, but the different order of circumstances or anything like that. So what I can do is simply upgrade this application. And in this case, I'm going to go ahead and call out that new image specifically. But this isn't always a necessary step. There's other ways you can automate this so that you can abstract even more of the application specifics from it. This is the name of my application as I've deployed it through Helm. And this is where my Helm chart location is. So what I'm gonna do is go ahead and upgrade this application to the, it should just be a slightly different color of the UI for that Go Figure application. And we can see here that this was a successful deployment. We can see it'll list out what images you've actually deployed. So now we've deployed that green image. And this is revision 2. So for example, if I needed to roll back and say this caused any issues, I can do that with Helm and I can manage that rollback access. But I wanted to catch this as it's going through. It's using Kubernetes deployment methods to actually go through and rolling updates of my web front end. So as each new container is brought up, a old container is brought down. So what it's going to do is automate the rollout of this new application. There are several ways that you can go ahead and do an application rollout. This is just the kind of the default Kubernetes way the deployment works is a rolling upgrade of services. And we can see here by the age of these, I didn't upgrade my Redis container, but you can see here that these new containers are all brand new. So this is actually the new version of my application. This new version of the application is still behind the same service within NSX. But what NSX does is dynamically update those endpoint selectors that are built into the Kubernetes load balancer type service. And then it automates that integration within that. So now my load balancer points to all of my new pods that are running within this namespace for this application. So if I go back here and I will open, so it doesn't cache anything. Oops. So now I have a, I think I meant to put it as green, but I have a slightly less blue updated application. So using Helm, I was able to go through and just upgrade that, point it to a new image, and have everything packaged as I'd expect, while still retaining all the different artifacts that I have, the ability to go back revisions from a Helm management perspective. And at the end of the day, it really just gives me the ability to package this application and deploy it as needed without having that detailed knowledge of the application itself. And we can see here, these are all the new pods that are deployed in there. We still have our PVC up in place, and we still have all of our networking components that are built out within NSX. And Helm isn't something that would be used just for your custom applications, right? Helm is also something that you can use to connect to different repositories. So if you have a Helm repository, which you can use Harbor for as well to house all of your charts, you can also pull down public charts. You can pull those public charts down through vSphere or through different VMware application services or the vSphere VMware application catalog. And then you can deploy known good services that are that can be like SQL servers or different things like that. And let's go ahead and so I just installed the repo, the stable repo. A lot of these are deprecated, but this is just an example of this is using a public repo for charts. But all of these applications I can deploy with one, just using Helm to deploy them. I can deploy them on my Kubernetes cluster without much of a hassle for management. And these are things that if you have several applications in your environment that you need to deploy and manage, if you go through the process of containerize those applications and preparing them from Kubernetes, you then can package each one of them into Helm, create all your different Helm charts based on applications, and then go ahead and lifecycle them that way on top of your vSphere environment. So for example, I can install, let's see, a WordPress, WordPress instance without really having WordPress anywhere going on. I can see, this is deprecated, so it might not work completely, but this is just an idea of how easy it can be. Helm can make for packaging applications to deploy them and then run them in your environment. Okay, that is everything that I had. So if there are any questions, we can take a look at those. So Megan, are there any other questions that we have on the demonstration for Helm and vSphere with Tanzu?
Yes, we have a question here that says, can we create our own Helm packages for in-house applications?
Yeah, absolutely. So that Go Figure application that we're deploying, that is actually, we own the source code for that. That's something that in this instance will be housed in, we use GitLab. So all of that is a custom application that we created the images ourselves, or the containers ourselves, and just simply use Helm as the packaging tool to do that.
Awesome. And there's one more question is, can this be built into a CI/CD pipeline on top of a vSphere as well?
Yeah, and that's actually a big benefit of being able to run your virtual machines alongside your Kubernetes environments, is that you can build in the tools that are required to run your CI/CD process as virtual machines, if that's how you're doing it today. Say, for example, if you have a Jenkins VM or if you're using GitLab as your Git store, you can run those as virtual machines alongside and use them to invoke the different pipelines that can use Helm as the endpoint to grab those artifacts and then deploy the application with those new artifacts. So a good point to make here is that this vSphere solution, or this VMware solution, VMware Tanzu, and what I've tried to demonstrate here using Helm is that even though this is a VMware product, a lot of people associate VMware with proprietary nature, that it has to be within the VMware ecosystem to run and integrate with vCenter. But as we just went through, Helm is an open source tool. I didn't have to pay for Helm, obviously. It's an open source tool you can download and start using as you see fit. And it integrates just as well as any other open source tool that runs on a Kubernetes environment. Yeah, is there any other questions? Hopefully that answered that.
There are no more questions in the chat box.
Okay, perfect. Well, I appreciate everybody taking the time to go over vSphere with Tanzu and deploying an application using Helm. I hope everybody got something out of this, and thank you guys for coming.